Right now, you are likely near, or honestly probably holding, a piece of glass and metal that processes billions of calculations a second.
Oh, yeah, definitely holding it.
Right. And it communicates with satellites in space. It holds the most private details of your life. And yet, if someone asked you to explain exactly how, like, a single text message gets from your screen to your friend's phone.
Or how that device actually, thinks to give you a search result.
Exactly. You probably couldn't. I mean, I couldn't. We built the ultimate machine, but
Okay.
we somehow skipped the manual.
It's a really profound blind spot that we all share. We navigate this highly engineered digital landscape every single day, but the underlying infrastructure is entirely invisible by design.
Yeah.
When it works, it feels like magic, and when it breaks, we just, tap the glass harder and hope for the best.
That is exactly why we are so thrilled to welcome you, the learner, to today's deep dives. We are looking at excerpts from this massive comprehensive guide. It's called Reading the Digital Future, Information II for High School Students and Lifelong Learners.
Which is quite the title.
It is. But while this material was originally built to give students a foundational mapping of information technology, reading through it, you realize it serves as like the ultimate decoder ring for any adult.
Oh, absolutely. If you use a smartphone or rely on cloud storage or ask an AI for advice, but you never got that formal breakdown of how the digital world actually works, this is 100% for you.
The central premise of the text is that information technology isn't just about operating a computer anymore. I mean, it's about decoding the digital society we already live in.
Right. Because if you don't understand the underlying systems, like how data is structured or how it moves and how it gets manipulated, you are essentially walking through modern life wearing a blindfold.
Completely vulnerable.
Exactly. Vulnerable to everything from basic data loss to sophisticated misinformation.
So our mission today is to take that blindfold off. We're going to decode those invisible systems you rely on daily. We'll strip away the jargon to understand the mechanics of how a computer processes reality, how data physically routes across the globe, and, the inherent responsibilities we inherit simply by logging on. So, okay, let's unpack this.
Let's do it.
Starting with the absolute raw materials of our digital reality. Because before we can really grasp the networks or the algorithms, we have to look at the massive gap between how a machine processes the world and how we do.
Yeah, and to highlight that gap, the source draws a really sharp distinction between three concepts we tend to just lump together, which are data, information, and knowledge.
Right.
They represent this escalation of meaning. So the text uses temperature as an example. If you have the number 32 and the word Celsius recorded by a sensor, that's just raw data.
It's just an objective, isolated fact.
Exactly. It's just a number.
But 32 degrees Celsius by itself doesn't actually tell you what to do. It only becomes information when you inject context. So knowing that 32 degrees Celsius means it is a hot summer day transforms that raw data into information that you can actually interpret.
And then the final step, knowledge, requires past experience and future judgment.
Oh.
So if you know that a hot, humid day increases your risk of heat stroke, so you actively decide to prepare a bottle of water before going outside.
Then you've utilized knowledge.
Precisely. And this highlights the core limitation of our devices. I mean, modern society is drowning in data. Our computers are exceptional at converting our physical reality into digital binary signals.
Right, the ones and zeros. Text, millions of colors using RGB pixels, sampling sound waves. They process all those ones and zeros at blinding speed.
Blinding speeds. But the computer doesn't actually understand the meaning of the 32 degrees.
And that is the ultimate boundary line, isn't it? Computers process symbols perfectly according to their instructions, but they have zero human common sense.
None. No actual context, zero inherent judgment. They just manipulate numbers. And the way they manipulate those numbers is entirely dependent on their physical architecture.
Which brings us to the desk analogy from the text, which I love. It's helpful even if you already know what a CPU or RAM is, because it perfectly explains the architectural bottleneck we all deal
It
with.
really does. So we all know the CPU is the brain doing the calculations, RAM is the temporary workspace, and the hard drive or SSD is the permanent storage.
Right.
But the text frames it as a workflow problem. Your RAM is the surface of the desk. When you open an app, the computer pulls data from the permanent bookshelf and spreads it out on the desk so the CPU can reach it instantly.
Right, it needs it close by to work fast.
Exactly. But the bottleneck exists because the desk has highly limited space, and crucially, it is entirely volatile.
Volatile meaning it needs continuous power.
Yes. If the power drops for even a fraction of a second, the desk is wiped completely clean.
which fundamentally explains the most universal modern frustration. When you are working on a massive file and the system crashes, losing your work isn't really a glitch in the software. It's an architectural reality.
Yeah, that new data only existed on the volatile disk. It never made the mechanical trip back to the permanent bookshelf.
That makes so much sense. So understanding that architectural divide, between processing speed and permanent storage, that's the first step to digital literacy. But a computer operating in isolation, just managing its own desk and bookshelf, is really just a glorified calculator.
Right, the real paradigm shift is what happens when that machine links to others.
Which brings us to the invisible highway. A computer only becomes a portal when it connects to a network. And the source breaks down how this data physically moves, starting at the local level.
The LAN or local area network, like what you have at your house or your office.
Right. And then it scales up to the WAN, the wide area network that spans cities and oceans to create the internet itself.
And what's really fascinating about the WAN is the engineering choice behind how it actually moves data. When you send like a massive video file across the internet, the network doesn't send it as one continuous heavy block.
Right.
It uses packet communication.
Yeah.
The system chops that video into thousands of tiny uniform pieces called packets. Each packet gets a destination address, and they are just thrown into the network.
Okay, wait. That seems incredibly counterintuitive to me. Like, you'd think chopping a pristine file into a million pieces and sending them on entirely different routes across global servers would be hugely inefficient and prone to errors. Why did we build the internet to work that way?
Well, we built it that way for resilience, actually. Think about it. If you send a file as a single block on a dedicated line and that line gets cut.
The whole transmission fails.
Exactly. But with packet switching, if a server in, say, London goes down, the remaining packets dynamically reroute through Paris or Tokyo.
Oh, wow.
Yeah, they all arrive at your device at slightly different times, completely out of order, and then your computer instantly reassembles them.
Which is wild. And it requires this invisible handoff that we take completely for granted, because those packets need precise numerical IP addresses to navigate.
Right, the numbers.
But humans can't remember a different string of numbers for every single website they visit. We use words.
So we rely on DNS, the domain name system. It acts as the invisible translator, like a phone book.
Exactly. You type in a contact name or domain name, and the DNS silently resolves that text into the numerical IP address so the network routing can actually happen. Here's where it gets really interesting to me, because this completely changes how you view a network outage. When your home Wi-Fi icon is fully lit, but a website simply times out, staring at your router is useless.
Yeah, your local LAN connection is completely fine.
It's the invisible handoff. Either the DNS is failing to translate the address, or the WAN is failing to route the packets. You have to troubleshoot the whole chain.
And because your data is bouncing through dozens of unknown servers across that chain, the text heavily emphasizes information security.
Right, keeping it safe in transit.
Exactly. It frames security not as like a single giant wall, but as a constant balancing act known as the CIA triad.
Okay, yes. Confidentiality, integrity, and availability.
Right. So confidentiality means only authorized people can see the data. Integrity ensures the data hasn't been altered or corrupted in transit. And availability means the systems are actually operational when you need them.
And the tension between those three pillars is really what drives modern tech design, right?
Oh, absolutely. It's a constant tug of war. Like, you can achieve perfect confidentiality by locking a server in a concrete bunker, disconnecting it from the internet, and requiring 5 retina scans to get in.
But then you've completely destroyed availability.
Exactly. The system is secure, but it's functionally useless.
Every tech company struggles with this. They want seamless availability, a frictionless user experience where you just click and buy, but they have to enforce confidentiality.
Which is why poor password management creates such a massive vulnerability. The text highlights this thing called credential stuffing.
Right, which is when you use the exact same password for, like, an obscure forum and your main banking app.
Attackers know people reuse passwords. So they breach the weak forum, steal the password, and then just have automated scripts stuff those credentials into every major financial and social platform.
So the network's integrity holds up fine, but the human element fails.
Precisely. And this is why multi-factor authentication is basically the mandatory bridge between confidentiality and availability now. You combine something you know, like a password,
With something you have, like a physical phone receiving a text code.
or something you are, like a fingerprint.
Okay, so we have this fragmented data safely navigating the globe, passing through security checkpoints, and finally arriving at your local machine. But raw, encrypted data sitting on a hard drive is useless if the computer doesn't know what to do with it.
Right. The machine needs rules. It needs a chef. It needs an algorithm.
An algorithm being a very precise, unambiguous set of instructions to solve a problem. Because, like we said, computers lack intuition. You can't just tell them to organize these files nicely.
No, you must provide explicit mathematical or logical steps. And the text points out that almost all of these complex algorithms are built from just three structural pillars.
Sequence, selection, and iteration.
Right. So sequence is executing commands in a strict top-to-bottom order.
Like the recipe analogy in the source, sequence is the order of ingredients.
Exactly. And the second is selection, which is the logical branching of if-then scenarios.
So if allergic to peanuts, then use almonds.
You got it. And the third is iteration, the ability to loop a process until a specific condition is met.
Stir until smooth.
Yes. When you combine sequence, selection, and iteration and map them to variables, which are essentially labeled boxes storing changing data, you can build highly sophisticated logic trees.
And the difference between a crude algorithm and an elegant one is staggering. Take searching for a file. The text contrasts a linear search with a binary search.
Oh, this is a great example. A linear search checks every single item one by one from the beginning. So if you have 1,000,000 files, it might take 1,000,000 steps.
But a binary search assumes the data is already sorted, right?
Right. It jumps dead center into the list, checks if your target is higher or lower, and instantly discards the incorrect half. And then it repeats that halving process.
So it can find a single item in 1,000,000 in just 20 steps.
Just 20 steps. It is a massive leap in efficiency.
But algorithms aren't just used for organizing internal files. They're also used to simulate reality. The source talks about modeling, using the example of simulating a crowd at a school festival.
Right. So you define the variables like hallway width, walking speed, number of attendees, and you introduce randomized iteration to see if a bottleneck forms.
So simulation allows us to test what-if scenarios without real-world consequences. What if we narrow this exit? What if it rains and everyone rushes inside?
Exactly. You let the algorithm play out the variables thousands of times to find the most likely failure points.
But wait, I have to push back here. If a model inherently simplifies reality to make the math computable, isn't it fundamentally flawed?
This raises an important question, yes.
Because by definition, a model is leaving out thousands of real-world variables, right?
It is, and that is a profound caution highlighted in the text. But consider a railway map, like a subway map.
Okay.
A subway map is a model of the city. It completely ignores the trees, the topography, the literal distance between stations. It distorts reality heavily.
Sure.
Yet that simplification is precisely why it's useful for a passenger trying to navigate the system. If the map included every real-world detail, it would be totally unreadable. The simplification is the feature.
Okay, I see. But the danger, then, is forgetting that the map is not the territory. When we blindly trust a model, especially in the realm of predictive AI, we really risk disaster.
Oh, absolutely. The source explicitly warns about overfitting.
Which is what exactly?
It happens when an algorithm is trained so perfectly on historical data that it completely breaks down when faced with a novel situation.
Ah, I see.
More concerningly, these models encode the specific biases of the humans who selected the variables. If an algorithm is designed to rank job applicants and the designer decides that years of continuous employment is the heaviest variable, the math will flawlessly filter out anyone who took time off for childcare.
So the algorithm isn't broken. It's actually executing the human bias perfectly.
Exactly, which is terrifying.
It really is. And that brings us to a crucial pivot in the text. Algorithms can spit out perfect, mathematically sound answers all day long. But if those answers aren't formatted and communicated clearly to the human brain, the entire system fails. We have to look at information design.
Yes. Communication in this context always involves a sender, a receiver, and a medium. And the choice of that medium dictates how the human brain will process the data.
The breakdown of strengths and weaknesses here is incredibly practical. Text is the ultimate medium for exact rules. It's searchable and precise, but it carries no emotional weight.
Right. And audio conveys urgency and tone brilliantly, but it is entirely ephemeral. It disappears.
Images communicate complex spatial relationships instantly, but they can easily strip away vital context.
And video is perhaps the most potent medium for demonstrating processes over time, but it demands a high cognitive load. And it can easily manipulate emotion through pacing and music, even when the underlying factual data is incredibly thin.
So what does this all mean? Well, just because our networks can handle massive, high-definition video files doesn't mean we should use them for everything.
Right.
The text points out that if you are designing an emergency evacuation route, a simple text list paired with a static graphic is vastly superior. You don't want someone forced to buffer a beautiful 4K video while the building is on fire.
No, you definitely don't. The medium must always match the cognitive state of the user, and delivering that medium requires data compression.
Right, because high-fidelity audio or images are massive.
Exactly. The system uses lossless compression for things like text documents or code, where every single bit must be perfectly reconstructed on the other side. A missing letter in code literally breaks the software.
But for media, we use lossy compression. The algorithm strips out imperceptible audio frequencies or minor color gradients that the human eye won't even notice.
It purposefully destroys a tiny fraction of the data to make the file small enough to travel quickly over the WAN.
But even with flawless transmission, the actual presentation really matters. The text draws a hard distinction between UI, the user interface, and UX, the user experience.
Yes, UI is the physical doorway. It's the buttons, the menus, the visual layout.
And UX is the psychological journey of navigating that space.
Yes.
So you can have a visually stunning UI, but if it takes a user 12 confusing clicks through hidden menus just to cancel a subscription, well, the UX is hostile.
The design completely failed.
Yeah. And my absolute favorite detail in the text regarding design failure is Moji Bake.
Oh, Mojibake, yes.
It's that frustrating moment when you open an email or a website and the text is just a garbled mess of random symbols, like weird wingdings.
Mojibake perfectly illustrates a breakdown in encoding. So the sender's machine translated the text into binary using one specific character code standard. But the receiver's machine attempted to decode that binary using a completely different standard. So the ones and zeros arrived flawlessly, but the failure to agree on the design rules rendered the information meaningless.
It's the ultimate metaphor for the digital age, really. The hardware works, the network delivers the packets, the algorithm executes the logic. But if the human at the end cannot interpret it, the entire stack is useless.
Totally useless.
Which brings us to the final and really the most volatile layer of the digital society. Us, the humans.
Yes, we've mapped the infrastructure, but the text heavily emphasizes digital citizenship because the human element is the ultimate wildcard.
For sure.
Every time you forward a link, query an AI, or post a comment, you are acting as an active node in this network, and that requires an understanding of the parameters we operate within.
The source outlines the baseline parameters well, like distinguishing between personal information, which is your literal name or address, and your broader right to privacy.
Right. Sharing an embarrassing anecdote about a friend might not leak their home address, but it definitely violates their privacy.
It also touches on copyright, reminding us that just because an image is indexed by a search algorithm, it doesn't mean the creator surrendered ownership.
Oh.
But the most analytical focus in this section is on how information cascades through a network, particularly regarding online backlash versus valid criticism.
This is such an important distinction. Criticism in a digital society targets actions, statements, or data. It's corrective. Backlash, on the other hand, targets the identity or dignity of the individual.
Right.
And in an ecosystem where data travels instantaneously, the crowd can accelerate a backlash far faster than facts can be verified, resulting in permanent digital damage.
And this directly fuels the spread of misinformation. The text observes a very specific psychological trigger. False information moves fastest through a network when it sparks intense emotion.
Oh, absolutely. Whether it's outrage, fear, or even overwhelming validation of something you already believe, that emotional spike bypasses your logical filter.
Your instinct is to immediately hit share.
Yes. And to counteract this, the source advocates for the pause method. It basically acts as a manual override for that emotional spike.
So if a piece of media triggers a strong reaction, you must intentionally stop. Do not forward the packets.
Cross-reference the claim. Inspect the date of the image because recycled media is a primary tool for fabricating context.
It's really the defining paradox of the digital citizen. I mean, we have spent the last 50 years engineering fiber optic cables, designing CPUs that process billions of operations a second, and building algorithms that instantly sort the world's data. Yet, our most vital survival skill in this hyper-accelerated environment is the discipline to manually slow down.
If we connect this to the bigger picture in the current era of generative AI, that discipline is non-negotiable. The text emphasizes that we must apply severe information judgment to AI outputs.
Because AI hallucinates.
Exactly. These models will confidently present hallucinations as fact, not out of malice, but because they do not actually comprehend truth. They only comprehend the statistical probability of the next word in a sequence.
Hmm.
So navigating this isn't just about following rules, it's about maintaining the integrity of the network itself.
So let's step back and look at the entire board. We have decoded the journey. We started with the raw ones and zeros, constrained by the physical bottleneck between the RAM disk and the storage bookshelf.
We watch those signals get chopped into packets, navigating the vast wands through the invisible handoff of DNS.
We explored how algorithms give that data purpose, how information design dictates its reception, and ultimately how it lands in our human hands.
The overarching takeaway from this manual is agency. You are not a passive consumer simply tapping on glass.
Right.
Every time you implement multi-factor authentication, every time you recognize an algorithm prioritizing sensationalism over context, and every time you pause before forwarding a volatile headline, you are actively maintaining the architecture of the information society.
The invisible systems only work if we understand our role within them. But I want to leave you, the listener, with a final thought to mull over.
Okay.
We established that computers process data flawlessly, but lack human judgment. We also established that our algorithms and predictive models learn how to simulate reality by consuming oceans of our past data. But humans are notoriously biased, highly emotional, and deeply flawed.
Which leaves us with a lingering dilemma.
Exactly. Are we using this incredible digital infrastructure to transcend our historical flaws, or are we simply hard-coding our human biases into the permanent algorithms that will govern our future?
Wow. Yeah.
It is absolutely something to ponder the next time an AI hands you a perfectly formatted, highly confident answer. The machine is working perfectly, but the reality it reflects is entirely up to us.